Good morning. I am Dr.P Divya, Department of Physics, Dr. MGR Educational and Research Institute University. Today we are going to see reverse carnot cycle. Reversed carnot cycle. What does this mean? Reversing the carnot cycle does not reverse the direction of heat and work interactions. So, we know that a refrigerator or heat pump that operates on the reversed Carnot cycle is called a Carnot refrigerator or a Carnot heat pump. The reversed Carnot cycle is the most efficient refrigeration cycle operating between two specified temperature levels. It sets the highest theoretical coefficient of performance. See the diagram here. It denotes from 1 to 2, refrigerant absorbs heat isothermally from a lower temperature source at temperature lower in the amount of QL. Similarly, the point 2 to 3 it denoting refrigerant compressed to the state 3, that is temperature rises to TH. 3 to 4 refrigerant reject the heat to high temperature at TH in the amount QH. Refrigerant changes from saturated vapor state to a saturated liquid state in the condenser. From 4 to 1, refrigerant expands adiabatically to the state 1, that is the temperature drops to TL. See the schematic diagram of Carnot refrigerator and the TS diagram of reversed Carnot cycle. So the condenser, turbine, evaporator, compressor was there. So the reversed Carnot cycle, it is showing the graph in this way. Reversed Carnot cycle consists of four processes. One is adiabatic compression, isothermal compression, adiabatic expansion, and isothermal expansion. See the graph which have been drawn between the pressure and volume. Similarly, the entropy changes with the temperature. From point 1 to 2, there was an adiabatic compression. It denoting the working fluid with the aid of external work. The temperature of the fluid rises from T2 to T1. Next one, adiabatic compression, that is isothermal compression, where it is the working fluid during which the heat is rejected at a constant temperature T1. From the point 3 to 4, it showing adiabatic expansion of working fluid. The temperature of the working fluid falls from T1 to T2. Similarly, the isothermal expansion of that where the heat is absorbed at a low temperature T2 from the space being cooled. Reversed Carnot cycle. The result is a cycle that operates in the counterclockwise direction on the TS diagram, that is the temperature entropy diagram, which is called the reverse Carnot cycle. Coefficient of performance of refrigerator. Heat absorbed Q2 equal to T2 into ds. Heat rejected, we already know it was Q1 equal to T1 into ds. Work input is equal to heat rejected minus heat absorbed. Now substituting, the heat rejected is Q1 minus heat absorbed is Q2, and substituting the values we will be getting T1 minus T2 into ds. Coefficient of performance of the refrigerator equal to cooling effect divided by work input. Cooling effect was given by QL divided by W equals to Q2 divided by Q1 minus Q2. Instead of Q2, you substitute T2 ds divided by Q1 minus Q2 is T1 minus T2 into ds. So the coefficient of performance is given by heat absorbed divided by work supplied is equal to heat absorbed divided by heat rejected minus heat absorbed. So we will be getting in terms of a temperature T2 divided by T1 minus T2. ds it will be getting cancelling off. points to remember. It was practically absorbed that the reverse carnot cycle cannot be used for refrigeration purpose, as the adiabatic process requires very high speed operation, whereas the isothermal process requires very low speed operation. Thank you.